Hello everyone, welcome to lesson 10.2, all about measuring angles and arcs inside of circles. Our goals today are going to be identifying something called central angles and various types of arcs. We will also be measuring those central angles and arcs and finding arc lengths, a different type of measurement relating to our arcs. So throughout this video, we're going to be introducing some vocabulary. We'll be doing some examples. Of course, you are encouraged to pause the video to take down some notes. Maybe pause the video before I begin diving into an example to give yourself a chance to look at it. So here we go. Let's start with central angles. Yep, there we go. So a central angle inside of a circle is an angle that has a vertex at the center of the circle, and the sides are made up of radii. So here we have circle C. We could call this circle C. And angle XCY is an example of a central angle. Okay, there it is. Now, in a given circle, as long as all of the central angles we're looking at do not overlap, then we know they're all going to add up to 360 degrees. It basically completes a full rotation in terms of degrees. So we would say the sum of central angles, as long as they're not overlapping, is always going to be 360. So as you might imagine, there can be some more complicated examples given this idea. So we're going to look at one of those. Here is circle Z. We've got several different radii drawn, so we have several different central angles we could look at. Notice two of them don't have any measures given, but I could also identify our diameter here. AZ is going to be a diameter, a chord that goes through the center of our circle. So using that fact, I can actually say that this whole angle, kind of made up of those two, that whole angle by itself is going to be 180 degrees. So I do actually know enough information here to solve for x given the other three measures. We could start off with a really simple equation stating that all of these add up to 360 degrees. So I'm going to write 360 is equal to 180 plus 75 plus, let's see, we've got one that's 5x minus 5, and the last one, 7x plus 2. Okay. So I might go ahead and combine kind of my like terms. We've got 180, 75, negative 5, 2. I know I'm ultimately trying to solve for x, so I'm really just going to go ahead and subtract all of that from both sides of my equation. Now at the same time, I might simplify things a little bit. I'll go ahead and add together my terms that have x. So that's going to simplify down to 108, and that's equal to 12x. Okay, not too bad. If we divide both sides by 12, we'll find that x must be equal to 9. Okay, so that really relies on us recognizing when we've got a diameter here, we've got essentially a straight angle, or we could also say even a linear pair, two angles that form 180 degrees. Now we could have also perhaps simplified and seen, well, on the other side of that straight angle, all three of these must therefore add up to 180 degrees as well. We could have just forgotten about the whole 360 and just started off with 180 equals the sum of those three. Okay, let's keep going here. Arcs. All right, so an arc is going to be actually the portion of the circle, so the curved part of the circle. And it is defined by two endpoints. So a couple facts about our arcs. A central angle separates a circle into two different arcs. We can kind of see that in this diagram here. We've got our central angle PQR, and we have, of course, one arc here in red, and then the other arc that's obviously much bigger there in blue. Now, the measure of an arc, if we're measuring it in degrees, we call that the arc measure, that is going to be equal to the measure of the corresponding central angle. So we don't have any actual angle measures given here, but let's just say we know that this angle measures, I don't know, it kind of looks like 120 degrees. If the measure of angle PQR is equal to 120 degrees, then the measure of my arc is also going to be 120 degrees. So we're going to be using our central angle measures and our arc measures, very similar to interchangeably. We'll add on to that a little bit here. Okay. Now, arcs can be congruent, meaning they have the exact same measure, but we actually expand that a little bit. We can say that arcs in the same circle with the same measure can be congruent, but arcs in different circles that are congruent and have the same measure, those can also be considered congruent arcs. So we could have two different circles. They've got to have the same radius in order to be congruent, but if they do have the same radius and our arcs have the same measure, then they are congruent arcs. All right, now our theorem relating to this here is that two minor arcs are going to be congruent if and only if, so here's our biconditional phrase, two minor arcs are congruent if and only if their central angles are congruent. So we can see we've kind of put this two ways. It is a biconditional phrase. If we know that angle 1 and angle 2 are central angles here, if those are congruent, then we know our arcs are congruent as well. But that flip-flops. Let's say we know instead, for some reason, we're given that the arcs are congruent, then we can conclude based on that that the angles are congruent. So that's, again, back to our biconditional. It's been maybe a while since we've talked about that in our class here. Okay. We can also describe arcs as adjacent. So adjacent arcs, kind of like adjacent angles to a degree here. Adjacent arcs are going to be ones that have one point, exactly one point in common. So we can see HJ and JK, those two arcs, share just one point. They're at J, so they would be considered adjacent arcs. We might also kind of expand this idea a little and see that, well, the central angles that they correspond to, HMJ and JMK, those are also adjacent angles, so their corresponding arcs would also be adjacent. Okay. So lots of information about arcs here. We're going to throw more at you. There are three kind of categories of arcs, three big categories of arcs. The first being a minor arc. Now, a minor arc is described as the shortest arc connecting 2 points. So we can see an example here of AB. We name these arcs with simply the endpoints. Now we're going to name this arc AB. So the letters with a little arc drawn over top of them. Now if we're trying to write out its measure, I'm going to have to use an M in front of this symbol, in front of the name, I suppose I could say. So arc AB is named with a little symbol over the letters AB. And if we're talking about the measure of arc AB, we have to include the little M beforehand. Now the measure of a minor arc, first of all, is always less than 180 degrees. It's always less than 180. It's also always going to be equal to the corresponding central angle. So I might add over here, if I've written the measure of arc AB, it's going to be equal to the measure of angle ACB. That's the corresponding angle we see in our diagram on the right. And we're also given that angle is x degrees, so we would say the arc measures x degrees as well. So minor arc always less than 180 degrees. Okay, we're going to flip-flop that for a major arc. Now a major arc is the longest arc that's connecting two endpoints. We're going to name these a little bit differently so that we can be a little bit more clear about what's going on. So we name these with 3 points. We use the endpoints, so again, we're looking at A and B as the endpoints. But to be clear that we're going essentially the other direction around the circle, we're going to use another point in between those endpoints, another point on the circle between my endpoints to make sure I know, well, this is the big one that we're talking about. So we would refer to this particular arc as arc ADB. And again, we're going to put our little arc symbol over those 3 letters. Okay. Now the measure of a major arc is always more than 180 degrees. Oftentimes, though, in diagrams, we're given just the measure of a central angle. So I'm not necessarily given this large angle around the other direction. However, I know that these 2 arcs, their measures add up to 360 degrees. These 2, the minor and the major arcs that we're talking about here, or really we could say these 2 angles also add up to 360 degrees. So I could say that the measure of arc ADB is actually equal to 360 degrees minus whatever x is. Since those 2 major and minor arcs would add up to 360 degrees. All right, so we've got one type of arc that is always less than 180 degrees, one type of arc that is always greater than 180 degrees. The last must be equal. So that's our semicircle. A semicircle is an arc with endpoints on a diameter. So it basically is cutting our circle in half. We do name these with 3 points, again, just to designate like which side of the circle we're talking about. So again, we're going to name the semicircle we see here arc ADB, or really we could call it semicircle ADB, but it's named in the same way with our little arc symbol. And the measure is always just equal to 180 degrees. So I might even add measure of ADB here. Arc ADB is 180 degrees. Okay. So those are our types of arcs. Let's keep going here. Okay, so I'm going to have you think back a ways to, I don't even know which chapters at this point, a ways back where we introduced segment addition postulates, angle addition postulates, all of these addition postulates that basically say the measures of these objects or figures, they can be added together or subtracted from one another. Well, we have an arc addition postulate, and that's exactly what it states. So our arc addition postulate says if we've got a bunch of arcs that are adjacent, so that's kind of key here, they need to be adjacent, then the sum of the measures of the 2 arcs form the larger arc. So we've got, let's call this arc XYZ. Now we're naming it with 3 letters. In this case, just to kind of clarify that we're like referring to this whole thing, we really could call it, since it is clearly a minor arc, we could call that instead measure of XZ, arc XZ. That might be a little bit better. So we're going to take whatever those individual arc measures are and add them together. Okay, so fairly simple there. And let's look at an example. There we go. Alrighty, so we've got our diagram off to the side here. Circle M with various radii drawn and various diameters drawn. And we want to answer the following questions. This might be a great place to pause and see what you can answer on your own. Now, my symbols are a little funky. These are supposed to be arcs, not like corners. We'll just run with it here. So let's start with number 1. We're trying to find the measure of arc LHI. Let's figure out where that is, first of all. LHI, here it is. So LHI, well, let's take note about some things going on in our circle M. We do have a couple of diameters, chords that go through the center of my circle. One of those diameters is LJ here. And you'll notice that if we kind of talk about this whole arc, we would say that that is a semicircle. You could say, in fact, let's write that down. Let's write that the measure of, what do we want to call that? We could say LHJ, LIJ, really referring to the same thing. LHJ perhaps is equal to 180 degrees. It's a semicircle. Well, I also have this lovely 90-degree angle marker. So I know that the measure of arc IJ is equal to 90 degrees. Remember, the measure of the central angle corresponds to the arc measure. So based on my arc addition postulate, I know that the measure of, oh, and I forgot my arc symbol there, the measure of arc LHI plus the measure of arc IJ is going to add up to the measure of arc LHJ. The only thing I don't know in this equation is LHI. The measure of arc LHI is my unknown, but I do know that the measure of arc IJ is 90, and they add up to 180. Therefore, the measure of arc LHI is going to have to be equal to 90 degrees. Okay. Let's move on to number 2, and I might move some things around just to make some space. So we're asked to find the measure of arc IJK. So let's identify where that arc is as well. Did I get it? There we go. Okay, so IJK is over here. All right. Now IJK, we could say, is made up of these 2 arcs, and one of those arcs is a nice 90-degree portion. We already identified that from before. The other, let's maybe just call the other one X for now. Now remember, arc measure corresponds to the central angle measure, so both of these would measure X degrees. I'm going to have you think back to, again, don't remember which chapter it was, a while back. We have a pair of vertical angles. Vertical angles are always congruent. That is our vertical angle theorem. So not only is arc JK X degrees and angle JMK X degrees, but also, because it is vertical, angle HML is X degrees. And that's kind of handy because I have a 90-degree angle here where I have a 32-degree angle portion. So I can find out what is the measure of X using Well, we could say using our arc addition postulate, but really we're kind of down to our angle addition postulate. 90 is equal to 32 plus x. Okay, so we'll take x and we'll add it to 90 degrees, and we'll find a total for the measure of arc, ijk, it's 148 degrees. We're using degrees here. Okay, now number 3, again, we'll kind of clear things up here a bit. We are asked to name an arc congruent to arc JK. Well, we kind of already talked about this a little bit. Again, we've got vertical angles. Whatever their measures are, those two angles, corresponds to the measures of their corresponding arcs. So JK would be congruent to HL or LH. All right, so a little bit of practice with our arc measure. But there is also something called arc length. So arc length is going to be a linear measure, like distance. Arc length is described as the distance between the endpoints along an arc measured in linear units. That's like centimeters, inches, feet, etc. So we're going to kind of use this idea, really we're going to be using proportions. So an arc, if we have, let's say, a circle, and here's, oh, that was a good circle. Let's say we have a central angle. So the arc we're looking at, let's say, is here. That is a piece of my whole circle. Just like my central angle is a piece of 360 degrees. We're really taking this idea and expanding to how much of my circle's circumference is this arc taking up. So let's look at our proportion. There's a better diagram of what I was trying to communicate. The ratio of, and we often use cursive L to represent the length of an arc, or arc length. So the ratio of our arc length to the circumference of the circle, which is given by 2 pi r or diameter pi, that is equal to the ratio of the arc's degree measure. Also, I could add here the central angle's degree measure, since those are the same, to 360. And we can write that, of course, as this proportion. So notice in our proportion, of course, 2 equal ratios, we have the piece of the circle, so part of the circle, I might say, over the whole circle. In one ratio, we have the distance, the linear measure. I'm going to call that linear measure here. And in the other ratio, we have the degrees, or the degree measure. Now, when I am thinking about memorizing, when I'm thinking about knowing how to find arc length, I really stick with this proportion. I try to always set up a proportion when I'm going to then solve for, let's say, the arc length of something. You can also, if this works better for your own brain, you can memorize this equation, which is essentially that proportion above, but solved for L, the arc length. So we would divide our angle measure or our arc degree measure by 360 and multiply that by the circumference 2 pi r. So if you think that is going to work better for you, I encourage you to stick with that. Let's finish this off with an example. Okay, let's erase some of this stuff here. So here we've got circle B. Okay, we want to find the measure. Measure, by the way, is to represent degrees, and the length, so that depends on what our unit is. We can see here our radius is given in centimeters, so our length is going to be in centimeters. We're finding both the measure and the length of arc AD. So we're after this piece. Now really, we can't do too much as far as length if we don't know its measure. So it's important really to start there. And again, I'm going to point out that we've got a diameter. AC is a diameter. So really, we've got a semicircle, meaning I can find the measure of AD by subtracting 28 degrees from 180. Let's write that down. 180 minus 28 is going to give me the measure of arc AD, again in degrees. Okay, and that's going to give me 152 degrees. So there's one piece of what we were asked to find. Now I'm going to need to figure out what my length is. And I do have my kind of proportion over here if needed, if we didn't write that down already. I like to really first find my circumference. It's given here as part of the proportion 2 pi r, but I like to figure that out first. So I see my radius here of 6 centimeters. That means my circumference, which is given by that 2 pi r, is 2 times 6 times pi, or 12 pi. I am going to leave our answer, by the way, in exact form for today. Okay, so let's set up our proportion. I don't know the arc length. That's what I'm trying to find. That's a piece of the circle. The whole circle, in terms of length, or circumference, is 12 pi. Now this is equal to, or is proportional to, the piece of the circle in degrees. We said that was 152. Compared to the whole circle in degrees, that's 360. So here is a proportion that we can solve. You can absolutely use a calculator for this. Again, I am going to ask that we leave it in exact terms. So leave pi out of your calculations for now. If we cross multiply, we'll get 1,824 pi equals 360 times my arc length. So of course, in order to solve, we're going to need to divide both sides by 360. The challenge becomes reducing that fraction. I want to give you a chance to think about that. And I'll go ahead and write our answer. This should reduce down to 76 pi over 15, or we could write it as 76 over 15 pi. I'm going to make sure I use my units of centimeters, not centimeters squared, just centimeters. And that is my arc length. Okay, so there are our two answers, 76 pi over 15 and 152 degrees. All right, go ahead and give this some practice yourself with our assigned homework for today, and of course, bring your questions to class. Thank you, everyone. Have a good day.